do another round also. I guess the why am I clicking leave the meeting now? I don't want to leave the meeting. Hold on. Advanced. I want to share portion of the screen. Think share. Just wondering. Oh, I can move this. It's good. So you should be able to see my screen a little bit. And I can move this away. So now let's do, what do we want to do? We want to look at that guy. So where did we stop last time? So, we covered how, how to read the values from the UI and how to get access to them in new simulation wizard.py. And the trick was, like, if you were lost totally and you didn't know where this readout from UI takes place, you could just do XML. And first, well, fortunately in this case, first occurrence of the word XML happens to be very close to the function generate XML, which, as we know, generate XML is the function that really writes the XML. The readout took place in earlier lines from, let's see, it's in the function generate new project. This function shouldn't be called generate new project, it should be called something different, but nevertheless, it is what it is, and this is where the readout takes place. So this is where we are reading from. So this is object that represents X dimension scroll box, and we're reading its value, and so on. All right. So there are a bunch of other readout places. We are reading the contents of tables for cell types, for chemotaxis, for diffusion solvers, and so on. But now we want to figure out like how to get those values and how to generate the XML that Pedro was just talking and explaining why we have wizard. And I think his explanation was excellent, because that's exactly why we have wizard. And I would only add that, even if you are good, like really good programmer, really good, modeler, tools like wizard save you time. The same way ChatGPT saves you time typing some, let's say you want to work on test suite. And this is mainly boilerplate code. If you use ChatGPT, it can do a lot of work for you. So why waste time when you have such good tools? Okay, so let's jump into this generate. Let's actually, what? Let me run it from scratch. I'm gonna bring it here. And let's walk through. So let's do simulation. So this will be lesson 2. Okay. I'm gonna change it to 258 so that there is some change. 11, I'm gonna make some changes. 1000. Continue. And B. C. Let's freeze this guy. Diffusion field. Yeah, let's add one. Continue. Add. Continue. Let's add contact, volume local flags, and this external potential. I think this will be planned. All right, and done. So we're gonna skip the readout part. I wanna advance immediately to this line, generate XML, okay? So I'm gonna hit play button. If you're using new PyCharm UI, the play button is somewhere here. I'm using the older UI layout, although the PyCharm is new under the hood. So we can step into this code, but if we step into this code, well, actually, let's do that. Why not? So we are inside the generate XML file, right? So we were here. Now we are inside this function. So what's going on inside the generate XML file? Well, first of all, let's look what generator is, because it takes argument called generator, right? So the argument is called generator. And if I open this, I'm going to try to open it in a separate tab. Let's see what type of object it is. So just looking through it. So this CC3D ML generator base, if we look at its content, it looks like actually the thing that generates actual XML. Why? Because I have function called generate pod section, right? I have function generate metadata section, right? I have function that says, I'm just looking, let's say generate cell type plugin, right? We'll definitely have cell type plugin. So why, let me actually put some breakpoints here. I'm gonna put in this guy and this guy. I already have breakpoints. All right. So let's go back to this place. So generate XML will fill this keywords dictionary first. So the first element of this keywords dictionary that we insert is called insert root element. And let's see what it is really. So generator and then CC3D. So if we look at this, it looks like this object, it represents a root element of our entire, like it's some type of root XML root element. So if you're, it might be actually good to review what a root element is and what I mean by that, because this terminology might be confusing if you haven't heard it before. Maybe I'm using it in a different context than you are used to. So let me go to demos and open like literally any, let's see, plugin demos. Let's open this guy. There's XML here. So I think what root element represents is this guy. So this would be our root XML element. So in XML, we have element, like the topmost, like top level element. I'm referring to it as root element, and it has opening tag and a closing tag, right? Inside the root element, I have children. I have pods. I have plugin volume. I have plugin center of mass. I have cell type. I'm collapsing everything here on purpose. And I have, so I have 1, 2, 3, 4 child elements, which are, and the elements are called plugin elements. And I have one steppable element. So this is this value, steppable, plugin, pods. This is the name of the XML element, okay? This is the attribute. And elements can have like really long list of attributes. So here, this is only one key value per cell. Type is the name of the attribute. Blob initializer is the value of the attribute. We go here, you can see the dimension element. So dimension is the name of the XML element of this element here. It has 3 attributes. They are named X, Y, Z, and the values are 200, 201. And that's it. Now here, this element, its name is Anil. This value 10 is called C data. Okay, so let's go back to the place where we are, and let's open up let's evaluate this element. Okay, so let's see what it does. So as I said, the name of the element is CompuCell3D. So going back here, so clearly this must be this element. So this object, CC3D element, represents this guy, all right? It has children attribute, but right now you can see that the number of children is 0. Okay, because we just created this element. We haven't not inserted children yet. Let's see, C data is also empty because we don't have anything between CompuCell3D, any string between CompuCell3D opening tag and closing tag. And yeah, so let's keep going. So for the data, we are passing cell type dictionary. So essentially, we're going to create a dictionary that will contain all the information that are necessary to construct XML. So this KWDS dictionary, keywords dictionary, let's call it, will contain all the data that we need to construct XML. And this data will be in, very like miscellaneous format. It can be, either in the form of, lists, dictionaries, nested dictionaries. We will see. Let's see. I'm gonna just quickly execute this, and I'm gonna inspect the content of this keywords dictionary. So general data, again, this is a dictionary that has a bunch of, entries, dimension, membrane fluctuation. This represents the pod section. What do we have here? Just looking. We have PDE field data. This is a simple dictionary that says, hey, we're going to have FGF field, and we want to use diffusion solver FE to create this field. And secretion data, there is no secretion data. Okay, so I think that's, and then we have cell type data. So data here represents dictionary that contains information about our cell types. And it's type name, cell type name, cell type name, cell type name, cell type name. And those 0, 1, 2, 3 are cell type IDs, and false specifies whether the cell is frozen or not. We had only one C-type cells that are frozen. All right. So I believe that this part here is the first place where we generate some interesting XML. Let me actually confirm. Let's actually, let's get into it. So what I did here, I tried to step into this function, okay? But you've noticed that instead of stepping into function called generate metadata simulation properties, I was dropped into function called decorator, okay? And the reason for this is that if I search, so let me actually search for this phrase, generate metadata simulation properties in this guide, you can see that this function, generate metadata simulation properties, is being decorated with a decorator, okay? So I'm not gonna talk too much about decorators because I don't wanna, go too deep into it, but decorators, in a nutshell, before they call functions that they decorate, so the function that's being decorated is this one, but there is a decorator on top of that. So before this function gets called, decorator will perform some additional tasks, okay? For example, let's say I have a function called, I want to call this function, but before calling this function, I want to write to a file, I want to write to a file the fact that I called this function. I want to log it, right? So I can create a decorator, a logging decorator, that before calling this function, so if you call this function directly from Python, if the function is decorated, when you interact with this function, you only call this function. But because it's decorated, Python will first call decorator and will perform, logging in that case, will write some information to a file, and then will call the decorated function, okay? So to make this story somewhat shorter, we can see, let's see what decorator does here, really. But I don't want you to pay too much attention to how this part works. It will be more interesting when we see actually how we construct XML elements, because when you will write your own functions, you will not care how the decorator is written. All you care really is, hey, how do I get the root element for the plugin or steppable that I'm actually working on? That's all you care. But I'm just giving you a little bit more context just so that you know. So let's look at the keywords. So keywords, it's the same dictionary that we saw before. Args. Let's see what args is. So args is, what is it? It's a tuple. It's essentially, looks like args is a instance of the CC3D ML generator base. Let's see what it does. Now, self-module name, level. I don't think it's really interesting, to be honest, here. I think I shouldn't maybe have been talking too much about this. Yeah, you know what, let's skip this. Let's pretend that there is some magic that takes place before you actually, so here we are getting to a point where we are calling decorated function. And in this case, our decorated function is this one, right? So, so now if I step into the decorated function, I'm going to be dropped here where I'm supposed to be. Okay, so what's going on here? This is important part, this self M element. So what is this? Because every single function that generates XML will begin like that. Okay, every single function. So let's see what the self element is. Okay, it's object representing XML element. Let's see inside. The name of this object is metadata. Okay. There is no C data here, and that's about it. Okay. So it looks like what this decorator did, so I will tell you what it did, not what it looks like. Initially we had CC3D, CompuCell3D element, but then the decorator inserted metadata. Is it metadata element, right? And we are getting this, where is it? This self M element is object that points to this metadata. So now our task is to fill the content of this metadata, right? So let's understand how it happens here. So let's go to this place. So when I'm saying here, add a comment, so I can, this CC3D XML element object allows you to insert comments, okay? So here what I'm doing is I am going to insert comment, and what I'm gonna do next, we're gonna talk about this plugin, this particular plugin. I'm gonna complete the wizard and we're gonna look at the results. So what's gonna happen that I will insert this thing, those two lines, insert a comment, and the comment will start with the new line, and the comment will look like this. Let me actually grab the text. It will look like this. Like this, and then I'm going to comment it out. So it will look something like that. Okay, that's what those two lines do. Next, I'm gonna insert new XML element called number of processors, The attribute list will be empty, but the value, the C data will be 1. So it will look like this. Let me actually grab this. It will look like number of processors. And this will be 1. Okay. Next, I'm going to output debug frequency. Again, I'm going to create element that's called debug output frequency with the C data equal 10. So let's do that. Sorry. And I think, just let me go back here. This new line inserts new line, I think. So there will be a break here. Debug out, now debug. Let me actually grab this guy. C. This. And it will be 10. And then I will insert element, and this is interesting pattern here. So this element will be called non-parallel module. Okay. So let's not worry what it means. Let's worry about content of XML right now. So mechanically, I'm grabbing this guy. I'm creating like that. Like this. But now my attribute list is not empty, which means that I will have attribute called name, name equals pods. So this is how, if you want to create attributes like this. Whoa, why does it look like? How about that? So if you want to pass attributes like here, you would pass them in the form of dictionary. And I think the last thing that's going to happen here is this element that I wrote like that. There is, it's going to be commented out. Okay. So I'm going to hit Apple / and I think that's what this element will look like. Right. So now, before going any further, let me actually complete everything. And I'm gonna just really quickly zoom through that. Okay, let's go to Tweeted, and I think Tweeted is completed. So let's see if I was right. Let me actually make it bigger. So let's see like that, and let's compare. So I have metadata, empty line. Then I added a comment, basic properties simulation. Then we had number of processors, debug output frequency. And then we added this non-parallel module, name equals pods, and then we commented it up. And then we are closing this. So now you see that by reading this code, where am I? I think I was, by reading the code of this function, I was provide one-to-one mapping between each statement here and each line in the XML. So to go through this again, this line, this metadata is represented by this object, okay? And for now, let's pretend that this object appears magically. It's not really magic, it's not magic because the decorator does the trick, okay? And I don't want you to get, back down or get lost in the decorator world. We can talk about it later, but you have to take my word. If you put this decorator and if you put module name as metadata, it will return you can get the metadata XML element using this syntax, like literally copy and pasting this syntax, right? So now we have that this element, M element, represents this portion of the XML. We are adding new line. Here is your new empty line, this one. Then we are adding a comment, okay? This is your comment line. Then we are adding number of processors element, okay? This is your number of processors element. Similarly, we are doing this guy, debug output frequency. That's where it is. Then we are adding that element, non-parallel module, which is here, okay? But then we also comment it out. After we edit it, we have option to comment it out. And the comment out is, this is how you comment stuff in XML or HTML or NML. Or yeah, not NML, but in XML and HTML. Does it make sense so far? So let's do another one. So now let's go. So this was easy example. Why it was easy? Because really we didn't use any values. We didn't use at all the values from our keywords, right? We didn't use any value from the UI. It was all arbitrary. By the way, let's do one more trick. Let's say I want to add elements here. An element. You know what? I'll just copy this. I'll call it hello. And I will show you. So this is seed data value. And those will be my attributes. X. Just wondering why. Okay, that's fine. 1, 2, 3. Then let's add CC3D. I don't know. So next time when we run the next simulation, this element should pop up, and I'll ask you to sort of like envision how this element would look like. You don't have to, it's not a quiz. You just think. I'm just curious if you already know how this element would look like. We'll see later on. We'll see the answer soon. So what I'm going to do, I'm going to create new project. And let me actually close this guy. So this will be lesson 3. Lesson 3. And I am going to, 11, let's do 2000. And then let's do ABC, merge those, FGF, and continue contact volume, external potential, done. Okay, so we're gonna switch to that part. I'm not gonna go through generate XML again. I am going to jump directly into here, pod section. Okay. So again, by now, if we put this decorator and we call it pods, this self M element will return object that represents pods. XML element, this guy. So what do we do now? Well, we can obviously check what is the value of self M element. So, and now you can see it's pods. So we are good. We are getting, what is this GPD? I don't know. Let's do self GPD. I think GPD stands for general properties data. And indeed, this is, or maybe general pods, whatever. Dimensions, membrane fluctuations, those are all friends from the second screen of the wizard, right? So Here I'm printing it out to the screen. Yeah, just to print out. And we know what this does. Introduces new line. Okay. We know what this does. It says, hey, no, add comment to the element pods. So essentially we'll be adding comment here. This is basic properties. Now, this is where we are going to create the dimensions element. So this is the place, this line that will create that line. Okay? Let's actually execute this. And now let's look at the value of M element in the evaluate window. M element. Is it M element like this? Yeah. So let's open it up. So M element is pods. The name of the element is pods. So this is this guy, right? But now this element should have children already. And it has already 3 children. So let's expand this tab. And I'm not sure if we'll be able to see the children here. Maybe we won't. Yeah, that's the bummer, actually. Maybe children list, isn't it? Let's see what it does. So there are 3 children here. What are the children, first of all? The children is empty line, comment, and dimensions. So if you expand children list, the comments and empty lines are not considered like real children. I mean, they are not technically. Those are like decorations of XML document. The first non-decoration element is called dimensions. So let's open it up. And indeed, it has dimensions. See data, there is no see data. It should have attributes. It has attributes here. So unfortunately, you won't be able to view those attributes because this is Swig object. But it doesn't really matter. We'll see how those attributes are getting translated into actual XML. But you know what the value of this is. This will be 258. This guy will be 258, 256, and 1. And if you don't believe me, I can do this for you. You know what? I can actually grab this whole thing and execute it here. Right? So this is the attribute dictionary here. And the same we can do for steps, temperature, and so on. And then the question is, what is the lattice type? So let's see what the GPD says. General properties data, GPD says about lattice property. Lattice type is square. So if lattice type is square, this line will not be executed. So let's see. Indeed, we skipped that. For dimensions now, here we can see if we introduce boundary conditions, but I don't think that we have any periodic boundary conditions for X, Y, or Z direction. So I think we'll just skip through that. Okay. So now we are going, so we generated pod section. So by the way, this generate XML has some logic in it. So first we generate this metadata, then we generate pod section, then we continue with, where are we? Then we continue with cell type plugin. Then we check. So here, let's actually go through cell type plugin and then we will see what's going on here. But you can see that essentially this is a sequence of if statements which have the same form. If volume flex check button is checked, so this is the last or second to last screen of the wizard where we check which plugins we want. If this is checked, we'll generate volume flex plugin. If this is surface flex check, we'll generate, plugin like that. And this goes on and covers every single plugin that Wizard supports. And then we will get to solvers. So this is where we will generate actually PD solver. But first, let's get through generate cell type plugin. So I have a breakpoint, so I'm gonna hit play. So now, what do you expect this element would look like? Well, its name will be plugin, and it will have attributes. Name equals cell type. So let's see if I'm right. So here I'm getting cell type data, which is my dictionary, which looks like that. And the M element here looks like this. And you can clearly see it's a plugin, but it has attributes. And attributes, well, you have to trust me, are name equals cell type. So by now, we are following the same pattern, new line, comment, and then we are iterating through those guys. So, we can cell type data, cell type data, and we are iterating through this dictionary. Okay, so type name is equal medium here, and tuple will be equal 0 and false. So let's see. So type name is equal medium, type tuple is equal 0 false, right? So we're extracting type ID is 0. We're constructing cell type dictionary. So those will be attributes, type name, medium, and then let's see how the cell type dict looks here. So cell type dict. So this will be the dictionary that represents our attributes. Okay. So at the end, my element that I'm inserting in this for loop, so those elements inserted in the for loop will be children of that element. Okay. And each element that I will insert will have name, cell type, and there will be attributes. Type equals 0, type name equals medium. Okay, so it will look like this. Cell type. Type ID equals 0, type name equals medium. Type ID equals 1, type name will be A in that case. So let's go through that. Right, and I think we're done. So let me actually finish this right now, and let's look at the results. Where are the results? Let's look at, go to edit, XML, and that's what we have. So this is how our pods element looks like. So we covered this in detail, we covered that in detail, and we covered this guy in detail. So those two elements, pods and cell type plugin, demonstrated how we can use values from the UI in generation of XML. Okay, so this I would say is the interesting part. What I would suggest doing next is I would suggest going through generation of the volume plugin. Why is this interesting? Well, because to generate this plugin, I have to use cell type data. Okay, I have 3 cell types, type A, B, and C. And I have to use the information about cell types to generate line for each cell type individually inside volume plugin. Or the same is true for external potential. So let's go through that. Then we can, I'm gonna skip external potential because the logic will be the same as here. Okay. Or actually, you know what, maybe we can focus on external potential and skip the volume part. Then I'd like to cover contact, because here we'll do double loop, right? We'll generate, because each element here contains information about type 1 and type B. So essentially, it lists all the possible combination of cell types in such a way that, you know, you don't want to repeat this element, because type 1 equals A and type 2 equals B is the same as type A equals B and type 2 equals A, right? So you want to avoid duplications. So this will be interesting. And then I think the final part will be the diffusion solver. Does it look okay for the plan? So let's do that. So lesson 4, I'm going to look at external potential. Okay. So before doing anything, I'd like to go here into CC3D ML generator base. External potential. And I want to put a breakpoint here, okay? Because, oh, wait, actually, you know what? I don't know. So there are 2 of them. There is external potential plugin and external potential flex. In CompuCell, the flex word, I'll explain what flex is. So if I defined volume, if I define volume like this, lambda volume 25, and then if I had, where is this? Okay, lambda volume, let's do target volume. Target. So if I define plugin like that, which is valid, this is not considered to be flex plugin. Flex plugin was the plugin that we had before, where we specify parameters individually for each cell type. So this is flex version of external potential. Okay. And then local flex is where the actual parameters are being set and adjusted in Python on the cell-by-cell basis. That's why it's called local. So, all right, so let's do lesson 4. Let's kill this guy, don't save, and lesson 4, same story. Lesson 4. All right, 11,000. It's fine. A, B, C. Freeze this guy. FGF. So, contact. You know, for now, I'm gonna do local flex version. And external potential will be also, yeah, we'll see what happens. I don't remember really how I coded it up. But I think this is all we had before. So I'm gonna skip the initial part where we read of the basic data. Skip that, skip pod section, we covered it, cell type plugin. Now I think will be dropped in the external potential plugin. No, let me actually go through that. So that's interesting. Clearly, this shows why it's useful to use debugger, because I didn't remember actually how it was called, but apparently we are being dropped into this function. So what is this element? Plugin name equals external potential. We know that. So in other words, our element, I can't even show it to you, but doesn't matter. So new line, comment, comment. So, and another comment. So we have 3 lines of comments here, right? This code, new line, comment, comment, and comment. Now, we're gonna create XML element called algorithm, and the C data will be pixel based. And now here, this is interesting. We have this structure called decorated cell type name. So let's see what it is. See, I don't remember. Cell type names. So decorated cell type names are really the cell type that occur in simulation except medium. So those are cell type names. So we had cell types A, B, C, and medium. But decorated cell type names is a list of all cell types except for medium. Well, good. So we're gonna iterate over this list, and in each iteration of the list, we're gonna create a dictionary that will specify attributes of the external potential parameters element. Okay, so and by the way, looks like I might have added something to some empty line somewhere in the code because I am off by 1 line. So I might have to stop debugging session and restart it. Let's look at the results here. Sorry, this guy. So let's go back to the code. So we were here. So remember, new line, 3 lines of comments. New line, like empty line, 3 lines of comments. Then algorithm pixel based. That's this guy. And then for each cell type, for each cell type, A, B, C, we are adding a line like that. And you remember how we construct those type of, if you want to construct something like that, what you can do really, if you have in your mind a vision for the XML element, you can, or you have a pattern, you can just grab it like that and, I don't know, open new editor, put curly braces and replace like that. Then we have to add quotes at the end. So this is how you would construct in Python the dictionary, the dictionary that corresponds to and I have to add commas. So this is how you would construct dictionary that corresponds to those attributes in Python. So this is more or less it. Now let's go and talk about contact. So I'm gonna close this for a while. Actually, you know what? Forget this. Don't save. I'll close it. Let's find word contact. Generate contact plugin. I'm pretty sure that this is where we want to be. So again, lesson 5. Continue. 11. So I'm just changing. I don't have to do it actually. Let's do blob, whatever. ABC, C, close, FGF. And we need contact, we need volume flex. I'm going to show you actually, we're going to come back to it later in a second. Because previously I picked, I think, volume local flex. Doesn't matter really. I think this is it. So let me skip few pod section, cell type plugin, external potential. Now we're in contact. Okay. So now, this is interesting. Let's look, because here I'm just looking at this part. Contact matrix. So let's try, let's see if this line executes actually. So it looks like I'm being dropped into exception handling part because keywords does not have contact matrix. Okay. Yeah. So it doesn't have contact matrix. The reason why this is written like that is because this function is not only used to generate de novo contact matrix or contact plugin, but it's also used to edit. Like, let's say you want to modify your contact plugin, you can use this, the same function. We were using the same function. So the same is true here, an order. So there is no an order, neighbor order in keywords. But this is familiar. We start with commented line. There is no new line, by the way. So for some reason, there's no new line. Now, this is interesting. The self-decorated pairs. I know what it is. Self-decorated pairs is a list of tuples where we list cell type 1, cell type 2 in such a way that we don't double count and we include every possible combination. So let's see if that's the case. And this one will include medium, I think. Created pairs. See? Medium, medium, medium AB, and so on and so forth. So what's going to happen is that we will iterate through that list. And for each combination of type name 1, type name 2, we'll create this dictionary of attributes that represent attributes. And what is contact energy matrix? Where is it defined? Oh, this is interesting. Oh, it won't be defined. Well, let's see. What is?
I think it's defined. I think I saw it being defined a little bit
Right.
earlier.
Oh, this guy, yeah. So this is a dictionary, right? So this is a dictionary. Yeah. So clearly this is empty dictionary. So if we try to look for anything in this dictionary, it has nothing, right? So not sure why it's saying try reverse the order. Oh, I know. So if we look for, let's actually go back here. If we look for, let's say, this element in this contact matrix called A and B. So cell type 1 is A, cell type name 2 is B. So if this line fails, then we say, hey, let's try reverse the order, meaning, hey, let's try BA combination. And this will also fail because at this moment, this particular moment, this contact energy matrix is empty dictionary. So it will fail. Yeah. If it fails, well, then we put default value. And this will be the story throughout this iteration. So we can, and then what we are doing, we are creating this contact energy element. So each element will start with energy. It will have combination of types and the value of energy. So let's go here. It's really funny. Let me actually open something different that has contact energy. I want you to see how it looks like. So for each combination of types, we will have energy element, the two types. That's self-decorated. So we have medium, 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 medium. Then we'll have medium A, medium B, medium C, and the C data will be 10 in our case. Why 10? Because of that. Because we don't have any contact energy matrix to begin with. We are starting de novo. There is no information. And so in this for loop, that's actually, let me make it. So in this for loop, we will insert the lines, we'll insert as many lines like that as there are those combinations. So we should have 10 lines. And at the end, we'll insert one additional line for neighbor order. And this additional line for neighbor order will be here. It will, instead of being called depth, it will be called neighbor order. So, I can go again. If you want to look how the attribute dictionary looks like, that's how it looks like. And so on. And I think I want to stop here. So I'm going to advance, and then we're done with that. So let's finish this and let's see how it looks like. This is your contact. Remember, medium, medium, medium A, medium B, medium C. There was AB element, and all of them have value of 10. The neighbor order finally was 4. That's what it was hard-coded in the wizard code. Okay. One thing, I don't know if you remember, previously our volume plugin had more content. It was like for each cell type we had entry, but now it doesn't. And the reason for that was, and let's do lesson, what is it, 5, 6? The reason for that was, I'm going to just maybe see GF. And the reason for that was that I picked volume local flags. If I put volume local flags, then the wizard will generate anything that says volume local flags usually ends up with one liner, meaning that all volume parameters have to be managed for each individual cell have to be managed from Python. All right, and I think that's, is there anything else we want to do here?
You didn't add your field. If you want to.
Oh, I didn't. Oh, that's a good point, because I wanted to actually go through generating of cell field, because I think this is, we will stop after that. I don't think there is really that much in the field generation. I'm sure you have seen most of it already, but let's see. Okay, so I'm going to continue, and let's go to, so pods, cell type plugin, external potential, contact. Now I have to find a way, a place in the code. Where is it? Where is this place in the code where I am generating? I'm generating. So those are all plugins where I'm generating the solver. So looks like that's where this will be. List of solvers. Okay, so I'm going to put a breakpoint here. And let's see. So we are now stopped inside. Where are we stopped? Come on. We are stopped inside our contact energy. Okay, so if I hit play again, I should be stopped at the list of solvers. So let's see what the list of solvers is. Well, there's just one diffusion solver because that's all we requested. Now here is interesting part. So we iterate over this list. We have just one solver. So here, this function, this object generator, what we are trying to do, we are trying to get attribute of this object generator that starts with generate and diffusion solver FE. So we're trying to get, so let me show you what we're trying to get. We're trying to find a function called generate, sorry, let's do this, plus solver. We want to find this function. And this function should be a member of generator. So get attribute and set attribute are built-in Python functions. So generator, not sure if it has. Doesn't look like it has anything, but if I type here, so dir lists every single property, including hidden ones, of the generator object. Unfortunately, here I have, can you see the diffusion solver? Yeah, I have a function called diffusion solver. So where we want to go is, so let's execute this. So this points, this object is a function called generate diffusion solver that is a member of the generator. And well, let's get into this. I was dropped in the decorator, obviously. So I'm going to execute every single line. Let's do it. I screwed up. I'm sorry. I should have done something smarter. I should have been here. But I'm afraid I missed it. So I'll have to do it again. So let me actually do it again real quick. Lesson. So I put breakpoint inside the generate solver. See, FGF. Be consistent. And find this, find that. So I'll try go really fast, and I want to get into, yeah, so generate solver. So now my module is called steppable, right? It's not a plugin anymore, and type equals diffusion solver. So this is what my M element represents. All right. All right. Okay, so everything, this is EV field data. There is no check if simulation is 3D. It is false. So simulation is not 3D. Comment. Decorated cell type names, we know what it is. So for field name, solver is diffusion solver, FGF. If diffusion solver is, if the solver is equal to diffusion solver FE, we keep adding predefined elements. So there's really nothing very interesting going on here. Let's see what cell type names is here. So there's nothing really interesting going on except, there's nothing here that we have not seen so far, okay? The only complications comes from the fact that the structure of the diffusion solver is more deeply nested than contact energy or external potential, right? But that's the only complication. We can keep going with this. I don't want to explain every single line, but I'm going to hit play. And let's finish this. And let's, sorry, let's go here. And I want you to take a look at this. So this is our M element. Then for each field that we have, we create open tag, diffusion field, okay? And inside diffusion field, we open another tag called diffusion data and secretion data. So this is actually the top level structure of the diffusion solver. So we have diffusion field, name equals FGF, because we wanted this field. And then we have diffusion data, secretion data, boundary conditions, 3 sections. So if we look at how diffusion data looks like, it's pretty straightforward. It's just like filling POTS elements, right? One by one. And this is all hard-coded in the wizard, right? Now, the reason I wanted to talk about diffusion solver, even though this is the last example, is that I think James would like you to add a page in the wizard where those values, where we can specify those values. So for each type, you could have a table that says, hey, what is diffusion coefficient for this cell type? What is decay coefficient for this cell type? What is global diffusion coefficient? So this thing, this part could be represented in user interface as a table, as an like Excel table. Like we've seen this before. We've seen this for cell type. This part, you would add 2 extra fields, and this could, and if we can do that, this would represent essentially this thing could be handled on a single page of the wizard. Now, the trick comes from the fact that we can have multiple fields. So let me actually show you real quick. Lesson. We can have multiple fields. I'm going to go real quick. So A, B, C. And then I have FGF, FGF8, and FGF, I don't know, 16, whatever. I have 3 fields. I'm not going to even bother with that. So let's skip this part. Let's focus on the diffusion solver. Okay, so we're in the diffusion solver world. Now, this dictionary, if we look at that, it's a dictionary with 3 elements. So it means that we'll have 3 sections in the diffusion solver. So I'm going to complete this and we'll take a look how those sections look like. Lesson 8. And I will stop at that point. So 1, 2, 3. So we have 3 sections. Each section begins with the diffusion field name equals FGF and closes, and there's a closing element for each section. If I zoom in, we are familiar with this one. So this part will be represented as table. Those will be line edits, I assume. This will be automatically filled. Now, actually, we'll see. What I would envision here, guys, let me actually go to, so because we have 3 fields, or we can have 4 fields, or however many, what I would envision is if I go to this tab, for each field, I would have FGF8, FGF8, FGF16. I would add a tab, and each tab would have a table here and 2 line edits, one for global diffusion constants, one for decay constant. Okay, table will take care of this section. Line edits will take care of that, and each tab represents a new field. And then you will have OK button or next button, whatever it is. And once you have those tabs for each field individually, you could read the values for those tabs individually in, just like we did with pods or with any other page in the wizard, and you will write XML. The trick is that you not only have this part that represents diffusion data, but you have also secretion data. Fortunately, secretion data is simple. Okay. So you will have secretion section where you say, A, B, and C. Actually, it might not be that simple because you can have different combinations like secrete on contact with, constant concentration, but we can take care of that later, I think. And then we have, for each field, we have boundary conditions. So, we can have constant value boundary conditions, periodic or constant derivative. All of that can be, should be coded up on a single wizard page. So essentially the content on this, not on a single wizard page, but single tab. So you would have few widgets that would, generate those guys, secretion data, and boundary conditions. So I'm gonna stop now because that's a lot. We covered a lot. And I guess I'm wondering if you have any questions. It's okay if you don't, because I know you're tired and I was talking too much as usual. But I wanted to give you stuff to work with. So what I would suggest, or Pedro will write assignment, but I would suggest just going through the same exercise that I went through. You can watch the video, you can just step through and try to see if you understand everything. And one last thing, not sure if you've noticed, but we've added this code somewhere. There's hello element in the metadata. So if anything, feel free to, just like I added, so let me actually search for the string here. Just like I added this element here, I want you to, play even with this function, generate metadata simulation properties, and put some dummy XML elements. See what you get out. Because as far as you are concerned, you don't really care how this file is getting written to a disk. It's actually very simple. There is a simple function that takes care of it. But really your task, or my task, if I want to add something to the wizard, is to just really add those elements. So you can be creative. You can create element like that, or you can even do something along those lines. Sorry. You can have element hello. You can have one. Sorry. See if you can create some, non-trivial hierarchy. That would be good exercise. And stepping through the code, and I think next meeting, what we should do, I think we should really design your start, I will get you started with this widget, this wizard page. I'm actually lesson, I think. This wizard page that will have, just wondering, so, you can have diffusion properties like you have here, and there will be tabs here. And yeah, I can help you. I can get you started with that, and then the rest will be your project. And of course, me and Pedro are here to help. So Does it make sense?
Yes. So I'll give them two simple tasks for the assignment.
Okay.
The first one is creating a dummy XML line like I did.
Yes.
And the second one,
Yeah.
there will be less it's not a challenge, but I won't give the precise steps. And the task will be to so can you go to the XML, the
Yes.
XML file?
Yes.
Yeah. So one thing that bothers everyone is in the diffusion solver steppables in the boundary conditions part.
Yeah.
People usually want by default the periodic boundary conditions to be uncommented and the other two, the constant values and constant derivative, to be commented. And this is already a fix in the
Yes.
opinion of a lot of people.
That's a good point. So, but before we do that, do you want periodic boundary conditions, or do you want like no flux boundary conditions? Meaning constant derivative
Equals 0.
0.
So
I would go with that one. But
yeah, you are modeling walls. Yeah, that's an interesting one. Yes. I mean,
yeah, I agree. I agree. This is annoying. This is annoying. Yeah, I completely agree. This is stupid.
yes.
Yeah.
So this will be a task for you, and
Yes.
this change will be implemented in
Yeah.
the next versions of CompuCell.
Exactly.
Which is
So
basically the you see in line 77, there is constant derivative, plane, position, the assignment will be to basically uncomment this line.
yeah.
And comment the other two, 73, 74. And
Yes.
have constant derivative 0 in all of them, in all boundary conditions X, Y, etc. And Z, if it's three-dimensional, also will have constant derivative 0. So this is simple enough.
Yeah.
And the challenge here is to find in the Python file, the Python code, where exactly these lines are being generated. So Maciej can show you already.
Yeah. So
where
if
they
I
are,
were to do
how to find
it, if I were to do it like literally what Pedro said, what I would say this. Let me find this word, constant derivative, inside the CC3D generator base. So I'm just literally going to the top of the file and doing the search. And I'm like, oh, looks like this is done. That's what he wants. So there is something going on. So I'm going to scroll up and see generate diffusion solver FE. That's where I am, right? And now it looks like I'm creating constant derivative here for X, but I'm commenting it out immediately, right? So we want to get rid of this line or comment, get rid of this line, set value 0 here. And that's our first task. Then we have to add another line for max. So there's position, minimum position and maximum position. Minimum position is always 0. Maximum position is wherever the lattice dimension is. And yeah, and you go like that. So I'm not gonna talk too much. I will just, I can give you a solution right now, but I don't want to give it to you. So that, I will let you have some fun. If you're stuck or whatever, I don't think you'll be stuck, but you can always ask.
Yeah, I'll write the assignment in a precise way, like how it is nowadays, and exactly how we want it to do, like the outcome, exactly the outcome. And then you try to figure out how to implement it in the CC3D generator base.py file. So there will be two tasks: the generating a dummy line in the plot section or wherever section, or a new section, who cares? And then fixing the boundary conditions part in the diffusion solver, which will be implemented. This I guarantee for you.
Yeah, so
will be implemented in next.
Yes, it will, but next time, how about we, Liam and Leo, how about you share your screens and show us how it works? If it works fine, I will ask you to make pull request. So we'll go through pull request and we can grab your call because you will be the authors of the fix. And yeah, let's do it like that. So
Liam,
it doesn't work, don't worry. This is not, we are not grading or, marking you down for like if 3D will not work properly. Let's see what you get. If there are issues, we can help you fix it. And then once we are happy with the way Wizard works, we'll get your code. We'll ask you to make pull request. And your fixes will be in the code. Because it's not like, it's, this whole project, it's more for you to actually learn. I don't know, do you guys learn all this stuff, in your computer science? Do they teach you like how to debug stuff? Yeah, but see, this is useful. You will use it like sooner than later. And like if you learn how to debug Python, if you work on React or like web pages or web apps, it will be the same thing. You will be debugging stuff. If you learn those techniques, that's why I always work in the debugger, because that's the way to write code, really. You will see it later. Now it might be too early, but okay, guys, I have to run. I think this was useful. I'm a bit tired, and I bet you're tired listening to me. Fortunately, or unfortunately, this is all recorded. But yeah, I hope you will have some fun with this. This is not very challenging assignment, but we'll use your code in actual next release. And there might be some other fixes like that, by the way. So Pedro, if you find something that's annoying that can be fixed, like with easy edits, like the one we talked about, let's do it too. And let's assign to Liam or Leo. I mean, to both of them, let's split. Right?
Yeah, thank you very much, Maciej.
Thanks a lot for sticking out.
Thank you.
Talk to you later. Bye.
Talk to you later.
Bye.